Today's objective is negative and zero exponents. Something that's really important you need to get in your mind is negative exponents do not give you negative numbers. Negative exponents give you fractions, okay? So it makes you think that it's going to be a negative number, like a negative integer, but it's not. So let's see why. We're going to do a pattern. You know that 2 to the third power is 8. And 2 to the second power is 4. Notice, to get from 8 to 4, I divide by 2, which is my base. 2 to the first power, you know that's 2, and when I'm decreasing from 4 to 2, I divide by 2, which is my base. So following the divide by 2 rule that we're doing here, 2 to the 0 power, well, what's 2 divided by 2? 1. 2 to the 0 power is 1. And now if I want to divide this by 2, what's 1 divided by 2? 1/2. And what's half of a half if I divide that by 2? Half of a half is a fourth. Let's watch. Let's do another one. So what's happening with my negative exponent is it's becoming a fraction. Because if I'm following the rule, if I'm dividing by my base each time, it just becomes smaller, but it doesn't go negative. It just gets closer to 0. So let's do 3 cubed. 3 cubed, 3 times 3 times 3 is 27. You know that. And 3 squared is 9. So, and 3 to the first is 3. So if I follow my rule and take 27, divide by 3, I get 9. 9 divide by 3, I get 3. 3 divided by 3 is 1. I'll write that so you can see. What's 1 divided by 3? 1/3. And what's a third of a third? 1/3 divided by 3, I'm going to write that out for you. 1/3 divided by 3 is the same as 1/3 times 1/3. Because remember, when we divide with fractions, we multiply by the reciprocal, and a reciprocal of a whole number, it's 3 over 1 is the number flipped upside down. So 1/3 times 1/3 is 1/9. See how we keep dividing by 3, 27, 9, 3, 1, 1/3, 1/9. Let's do 4 to the third. 4 to the third you usually don't do. It's 4 times 4 times 4, but it's 64. 4 squared, you know, 16. 4 to the first, anything to the first power is just the base, is 4. And so we're following the pattern. If you look at the numbers also, divide by 4, divide by 4. 4 divided by 4, 1. 1 divided by 4, 1/4. 1/4 divided by 4, that equals 1/4 times 1/4. So that's 1/16. So you can see how, if we follow the pattern, and mathematics is all patterns, well not all, but a lot, that our negative exponents are just giving us smaller numbers. So as the exponent goes down, the worked out value goes down, but it doesn't turn negative. So this pattern always works. Any non-zero to the 0 power is 1. Notice that 2 to the 0 is 1, 3 to the 0 is 1, 4 to the 0 is 1. X to the 0 would be 1, 14 to the 0 is 1. Negative 27 to the 0 is 1. 4xy squared quantity to the 0 is 1. Alright, so let's talk some more about it. However, in algebra, we like to change negative exponents to positive exponents in our solution, just like we don't need to like to say negative x equals. So use the information from the other slide, and let's look and see. Remember, we had 2 to the negative 1 is 1/2. Well, we could say 2 is the same as 2 to the first. 2 to the negative 2 power is 1/4, but 4 is also 2 squared, so it could be 1 over 2 squared. 2 to the negative third was 1/8. We didn't write that on the other one, but it makes sense, right? If we divide 1/4 by 2, we get 1/8. But 8 could be rewritten as 2 to the third. So we can rewrite our negative exponents in the base with a positive exponent. You can think this is the base. I should have said in the denominator. In the denominator with a positive exponent. Because we could really think of this as 2 over 1. 2 over 1. 2 over 1. So these numbers are really in the numerator. All whole numbers are really in the numerator with a denominator of 1. And to make the exponent positive, we move it to the denominator. Let's look at thirds and fourths also. So 3 to the negative 1/3 we said was 3 to the negative 1 we said was 1/3, which could be written as 1/3 to the first, or 1 over 3 to the first. 3 to the negative 2 could be rewritten as 1/9. That's what we did on our other slide. And 9 can be rewritten as 3 squared, so 1 over 3 squared. And 3 to the negative 3 is 1 over 27, but 27 could be written as 3 cubed. So see, we're changing our negative exponents to positive exponents by changing our whole number into a fraction. But really, we're moving what was in the numerator to the denominator. Okay, because we never think of whole numbers as being in the numerator, but they are. Same with fourths. Let's do the pattern one more time. 4 to the negative 1 is 1/4, or 1 over 4 to the first. 4 to the negative 2 is 1/16, but 16 can be written 4 squared, so 1 over 4 squared. And the same with 4 to the negative 3 can be written 1 over 4 to the 3. So I'm asking you, do you see a pattern? When a whole number has a negative exponent, you move the base, which is the whole number, to the denominator and make it a fraction. And when the exponent is moved to the denominator, it becomes positive. So that's how we get rid of our negative exponents. We rewrite it, change the position of the base. Basically, to make a negative exponent positive, you change the position of the base. If it's in the numerator, it goes to the denominator, or if it's in the denominator, it moves to the numerator. I'll show you one of those. So let's just do a couple. 5 to the negative 2 becomes 1 over 5 squared. You could write that as 1 over 25. X to the negative 5th becomes 1 over x to the 5th. 3, y to the negative 2. Now the 3 does not have a negative exponent, so the 3 stays in the numerator. But to make the negative exponent positive, the y squared goes down in the denominator. That's kind of tricky, huh? How about 4x over y to the negative 2? Well, the 4x stays in the numerator, and to make this negative positive, you have to change the position of the base. This was in the denominator. It moves up to the numerator because you could rewrite this as over 1. We just don't do that. Here's another one. 3a over b to the negative 6. The 3a stays in the numerator, and the b6 comes up and becomes positive when it changes position, when it goes from the denominator to the numerator. All right, let's do one more thing. So the basic exponent rules that we did on the last exponent video also apply to negative or zero exponents. So remember, when you're multiplying with exponents, if they have the same base, you just add the exponents. So 5 to the 10th times 5 to the negative 5 equals 5 to the 10 plus negative 5, which is 5 to the 5th. You still add the exponents. 3 to the 8th times 3 to the 10th. I'm showing you the work that you could be doing in your head, but 8 plus negative 10 is negative 2, but we don't leave it like that. We rewrite it 1 over 3 squared because we don't want negative exponents in our final answer. How about if we have 8n to the negative 3 over 2n squared? I'm going to take it all apart. Okay, so 8 over 2 times n to the negative 3 over n squared. 8 over 2 simplifies to 4 over 1. And remember, with division, you subtract your exponent. So we have negative 3 minus 2. Now we get 4n to the negative 5th. But we don't want to have a negative exponent in our final answer. So it becomes 4 stays in the numerator and n to the 5th in the denominator. Now in the book, they have you rewrite some things without saying, it says rewrite without a fraction bar. So I'm saying sometimes you need to simplify and write your expression without a fraction bar. And I want you just to think of it, it's just more fun manipulating numbers, okay? I don't really know why the book has you do that, but I want to explain it to you. So they say rewrite 1 over 25, 1/25 without a fraction bar. So we simplify 25, it's a perfect square, to be 5 squared. And then we rewrite it and say we say 5 to the negative 2. So you're just manipulating the numbers back and forth to understand how they move. We would never have a final answer like that, okay? So if I have 2 over 8 to the x, how do I get rid of the fraction bar and move this into the numerator? Well, if it's positive and I move it, it becomes negative. So it's 2x to the negative 8. And here's one more, x to the 7 over y squared. X to the 7 stays in the numerator, and it becomes x to the 7 y to the negative 2. And here's one more we simplified. 1,000. 1,000 is 10 to the third power because the 10 powers are so nice. The number of zeros is your exponent. But to get rid of the fraction bar, we would have to write it 10 to the negative 3. So let's try this one. This is a fun one. 4x squared y to the 0 z to the negative 3 over 12x cubed y to the negative 2 z to the 4. So I'm going to take it apart, and 4 over 12 becomes 1/3. The x's I need to subtract, so 2 minus 3. The y's I'm going to subtract, 2 minus negative 2. And the z's I'm going to subtract, negative 3 minus 4. So when I simplify everything, my 1, I don't need to do anything. What's 2 minus 3? Negative 1, so I'm going to have to move that. 0 minus negative 2 becomes 0 plus 2. Negative 3 minus 4, negative 7. And that's all over 3. So when I rearrange everything and get rid of my negative exponents, it just becomes y squared, because this is a negative, so it's going to go in the denominator, and that's a negative, so it's going to go in the denominator, over 3x z to the 7th. And notice when I move the negative 1, I don't write the positive 1 down there, because we don't write that for when the exponent's just 1. So I think that's kind of fun. I think this is the part you get to do when you learn everything. All right, that's it.